All right, so we are talking about some new figures today. We're still looking at quadrilaterals, but we're getting away from parallelograms. And parallelograms had two pairs of parallel sides. Now we're talking about trapezoids, and a trapezoid has exactly one pair of parallel sides. And you see that in the definition, the word exactly, because it's exactly one pair. It can't be two, because two is a parallelogram. So everything that we're talking about today in terms of a trapezoid, you need to know it has that one pair of parallel sides. Okay, other things to know vocab-wise about this. The parallel sides are called the bases. Okay, the bases, and we see that in our formula for area. We're not necessarily talking about area today, but the formula for area of a trapezoid talks about base 1 and base 2. Okay, the parallel lines, those are the bases. Your base angles are thought of as pairs, okay, a pair of base angles. So you can either talk about this pair of base angles or this pair of base angles. So either the pair of angles that surround either base are going to be your base angles, okay? So you see the definition, right? Two consecutive angles whose common side is a base. So it's that surround that parallel line, that base, okay? The non-parallel sides are the legs of the trapezoid. So we'll see some information, some theorems, but today we're really concentrating on this idea of an isosceles trapezoid. Okay, yeah.
Can a parallelogram be a trapezoid, or can it only have one?
It can only have one method. Yeah.
So technically every parallelogram is a trapezoid, but no trapezoid is a parallelogram.
Nope, they're completely separate things. Trapezoid has one pair of parallel sides, parallelogram has two. Right? So we can't, there's no overlap in that Venn diagram between the two. So we're talking about an isosceles trapezoid. And what makes an isosceles trapezoid special or specific is the legs are congruent. Okay, so this is not the typical trapezoid. This is a special trapezoid, special trapezoid where the legs are congruent. Okay, and our theorems that we're going to see deal with that isosceles trapezoid, because there's more we can say specifically about this type of trapezoid. Right, because trapezoids come in all shapes. We saw it in the warm-up. Right, that's a trapezoid. Okay, this and this, and we're not going to be able to say the same information about these two when it comes to diagonals or it comes to other things. So we're concentrating only on that isosceles. Any questions on our vocab section there? Okay. All right. So you might see this type of problem in there that's saying, show that this is a trapezoid. How can we prove that something is a trapezoid here? Luke?
You find the slope of RS and TO.
Yeah, you find those slopes. If they're the same, they're parallel, so it's a trapezoid. Okay? And then it says decide whether it's isosceles or not. That's the distance formula. All right? That's looking at your two legs and saying, are they the same length? So slopes of your base, right, to make sure that they're parallel. Distance formula for your legs to see if they are congruent. In this case, they are not congruent, so this is a trapezoid, but it is not isosceles. Okay. All right. Moving on. Let's look at our theorems. So we got 3 theorems here, 3 in a row, talking about the isosceles trapezoids. First one is the isosceles trapezoid base angles theorem. And this really is the same idea as our base angles theorem was before when we dealt with isosceles triangles. Now we're dealing with isosceles trapezoids. Okay, it's the same idea. In fact, if we were to continue on these legs, if we were to continue these on and draw these up, it would form an isosceles triangle. Okay, so this is really just an isosceles triangle that's cut off so that the top and bottom are parallel. So our base angles theorem here, just like the triangle one, says if we know our legs are congruent, then the base angles it's gonna hold true for both pairs of base angles. So the bottom base angles, the top base angles will be congruent. Okay, that's if the legs are congruent. Okay. And then we go with a converse. So that same idea, just in reverse. So this is, if a trapezoid has one pair of congruent base angles, so if we know one pair of base angles is congruent, whether it's the top or the bottom, doesn't matter. But if you have one pair of base angles congruent, the legs are congruent as well, and which makes it isosceles. So we can kind of go back and forth between those. If the legs are congruent, the base angles are congruent, vice versa. Any questions on those two? Those two kind of go together. What can you tell me before we hit this third one? What can you tell me for sure about those two angles? What has to be true about those two? Taylor? Yeah, they're CIA, just like we talked about in the warm-up. They're CIA, they're consecutive, have to be 180. So we know in any trapezoid that these are going to be supplementary. But in isosceles, right, if you know two of them, you know the other because they're going to be congruent if it is isosceles. All right, our third theorem here about isosceles trapezoids deals with, of course, diagonals, because that's seems to be all that we talk about now, are the diagonals of figures. But a trapezoid is isosceles if and only if its diagonals are congruent. So just like our rectangle theorem, right, our rectangle diagonals, only now it's the trapezoid and not a parallelogram. Okay, it was just a parallelogram if the diagonals are congruent, then it's a rectangle. Now we're not talking about parallelograms, we're talking about trapezoids. So if our trapezoid has congruent diagonals, that means it is isosceles. Okay, and vice versa. If it's isosceles, then I know the diagonals are going to be congruent. This chapter has a lot of information, a lot of properties that we have to keep straight. For the test, that's going to be your biggest challenge, is to keep all of these straight of, all right, it's a rhombus, what can I say about it? What can I say about rectangles? What can I say about trapezoids? What can I say about kites, right? Just keeping all of that straight. So whether that's strictly studying your notes, whether that's making flashcards, whether whatever, you got to keep those straight, okay? And be able to apply them when it's time. All right. Okay, so there's our trapezoid. I want you to talk to somebody about those two questions, please.
Number two, yeah, I'm not sure. Because, well, yeah, you can say
Yeah. Well, I think it's angle E would be 70, angle G is
All right, for number two, if EG and FH are equal, is this isosceles?
yes.
Yes, right? That's the diagonal theorem, we know that. The real question comes in on number three. Is this enough to say that our trapezoid is isosceles here? Tyler?
Yes, because we can do consecutive interior angles to say angle FGH, that is GFE is equal to 180. So then 70, and then you can do the same thing for the other side.
Perfect, yeah, because we've got those parallel, we talked about CIA. If this is 110, this has to be 70. If this is 70, this has to be 110. So now I've got consecutive base angles that are congruent. So I can say that it is isosceles. Good. At first blush, you look at it and you think, well, those aren't CIA, so we can't say anything. We got to do a little bit of work on that to be able to say yes. Okay, any questions on those three trapezoid theorems?
Do you need all four base angles, or do you just need two?
You just need to know that two are congruent.
So you didn't need to say that the other one.
We didn't need to do that fourth one.
Right.
Yeah, as soon as we found 70, 70, that's enough. All right, we got one more about trapezoids. And again, this is very similar to a triangle theorem that we have. First of all, talking about mid-segment, we know what a mid-segment of a triangle is. It's a mid-segment of a trapezoid. This one does not have to be isosceles. This is the one out of the four that does not have to be an isosceles trapezoid for it to work. So we're looking at the mid-segment. And the mid-segment is just connecting the midpoints of the two legs. Okay, it's not dealing with the bases at all. It is connecting the midpoints of the two legs of our figure. Okay, that's our mid-segment. We know that it's going to be parallel, right? Just like our triangle one was. It's going to be parallel because that should make sense. At the top and bottom are parallel. We're cutting it in half. That middle one's going to be parallel too. And then if you recall back to the triangle one, the mid-segment was half of the parallel side. It's not half of the parallel side anymore. It is the average of the two lengths. Okay, so the mid-segment is going to be the average of our two base lengths. So putting that visually, all right, if I know this is 8 and this is 12, we take the average, the exact middle of that, we're going to know that our mid-segment is 10. Okay, it is the average of those two numbers. So you're going to see problems where they give you 2 out of those 3 pieces of information. You have to find the third one. Nice and easy if they give you the outer 2, right? Add it together, divide by 2. We're just taking the average. But I want you to talk to the person next to you. What are you going to do if they give you this is 7, this is 15, and they want that? Talk to the person next to you. What are you going to do?
The first time, so you have to go up by 8 again.
Or you just mathematically.
All right, what are we going to do? So we get this. Yeah? Yeah, because we added 8 to get here, right? We've seen this sort of before with the midpoints. If we added 8 to get here, we got to add 8 more to get there. That's going to guarantee that that 15 is exactly in the middle. So we do 15 plus 8. Hopefully you get that right. That's 23. Okay. The other way would be to multiply 15 by 2 and then subtract the 7. I think this way is easier. All right. Good deal. Questions about our trapezoid mid-segment here? Okay. I want you to recap those 4 trapezoid theorems in some way, please.
Yeah. I got it wrong. It's like process with the diagonal Well, no, we have to go. Yeah. Yeah. Yeah, but some sort of like-
All right. Any questions on the trapezoids? All right, moving on. We're gonna talk about kites. There's a reason that the things that you fly in the sky are called kites, is because they follow the shape of a kite. Okay, the mathematical term of kite. So the mathematical definition here of a kite, quadrilateral, so it has to have four sides and only four sides. Two pairs of consecutive congruent sides. Okay, consecutive congruent sides, which means they are right next to each other. They are congruent. And then they tell you, but opposite sides are not congruent. Because if opposite sides were congruent and we had consecutive congruent, it's a rhombus, right? It's a rhombus because then all four would be congruent. So a kite is very similar to a rhombus, but we are stretching one of the corners away, right? If we drew in a rhombus would be more like this. If we just take that and pull it out, that's now a kite, okay? So it's very similar, and you're going to see that similarity in the theorems, right? Because they are very close to the rhombus theorems. But this is our definition. You got two pairs of consecutive congruent sides, there and there. Okay. So when we go to our theorems, our first one talks about the diagonals. Okay, and just like that rhombus theorem, our perpendicular or our diagonals are going to be perpendicular. Okay, they're going to be perpendicular. Again, if I just had that rhombus in there and I just pull that one vertex out, that's not going to change what's happening with the intersection of my diagonal. Right, so diagonals are going to be perpendicular. That helps us to solve angle problems because we know we've got that 90. We know we've got right angles. We can use triangle sum theorem a little bit easier. Okay, that allows us to do a lot of things there. Okay, so diagonals are perpendicular. The other one talks about opposite angles theorem. Okay, opposite angles theorem here says you have exactly one pair of opposite angles that are congruent. Just one. Okay, again, if we had both pairs of opposite congruent, that would be a parallelogram. It's not. So we have one pair. And the pair of angles that are congruent are the ones that are formed with the two different side lengths. Okay, between the two different side lengths, those are the ones that are congruent. This and this, obviously not congruent. Okay, these two are. Okay. Questions on that? Okay. So, if we look at that, hold on. Let's look at the top picture here. Look at this one. Okay, so we know that these two angles are congruent, right? That's what that other theorem told us. What can you say about the angles B and D? What can we say about angles B and D here? Kara? Okay, B is greater than D. Yep. So they're not congruent. B is greater than D. What else?
Could you say that B is double D?
We don't know that for sure. It could be. We don't know for sure. Hold.
They're being bisected by the diagonals.
Yeah, they're being bisected here. Okay, they're being bisected. And the reason why we can say that for sure is if you look at the top triangle, the bottom triangle, right? That triangle and this triangle. Based on the information given, we have SAS, right? Side angle side. The big triangles are congruent. Top and bottom are congruent, which means CP, CTC, those have to be congruent. And then these have to be congruent. I don't know why I did that. Okay, So those angles are bisected. So we don't have a theorem about that, but we know just because of triangle congruence that these are congruent, these are congruent. It's always going to be that way. Okay, we have other triangles that are congruent. These two smaller triangles are congruent. The smallest triangles here are congruent. The big top, the big bottom are congruent. There's a lot of congruency going on. Okay, and we can use that fact to solve different problems when we come across it. Yeah.
For the diagonals, could you say, let's just say that, the point where all the diagonals meet is E, couldn't you say that C, E, A, E, and D, E are all congruent?
We can say for sure that these two are. We can't say anything for sure there. Okay, but yeah, we can say up and down, those are congruent.
So you can't use consecutive anymore then, because it would give us the same answer for both.
Yeah, you can't use consecutive because there's no parallel lines here. Yeah. Yep. Okay, anything else on this? Okay. Good, so even though it's not a theorem, we still can't say those other things about the angles being bisected, triangles being congruent, right? We've got a lot of stuff that we can kind of show there. I want to show you this little chart, kind of breaks up our quadrilaterals into our different categories, right? All of these things are quadrilaterals. Quadrilateral is just 4 sides. So we got a ton of different quadrilaterals, but then we break it down. Parallelogram has 2 pairs of parallel sides. Trapezoid has 1 pair of parallel sides. A kite has 0. But a kite is not just any quadrilateral that has 0. It has to specifically be these are congruent, these are congruent. So really, there are some quadrilaterals that are none of these. Right? I mean, I could draw just some random quadrilateral that's none of these. Okay? So we have these 3 specific ones that we talk about. Inside the trapezoid, we could have isosceles or non-isosceles. Within the parallelogram, we could have rectangle, rhombus. Both of those lead into square. All right, so just we can break these down, and you're going to see questions that ask you to give the most specific name possible for it. So that's where you need to look at those properties and say, all right, where are we on this little flow chart? Okay. So speaking of, let's look at these 3. Talk to the person next to you. What's the most specific name that we could give for the quadrilaterals?
Oh yeah, one is like 9 is
The diagonals are congruent. Yeah.
Well, that's only because isosceles.
Oh, yeah, you're right.
Hey. I heard somebody else. The first one's a kite.
All right, let's see what we think. For the first one, for number 8 here, raise your hand. What type of figure do we have for this one? Austin?
a kite,
It's a kite. Why is it a kite?
because the ST and SR are congruent, and then RU and TU are congruent.
Yeah, there you go. Got 2 pairs of consecutive congruent sides. That is a kite. How about for number 9? What can we say there? Tyler? Trapezoid. Trapezoid, and that's the most specific that we can be. It is not isosceles because the diagonals are not congruent to each other. So it's just a trapezoid. How about for 10?
Huh? Me?
Did you say something?
Yeah,
What did you say?
rectangle.
Yeah,
Not a rectangle.
Oh,
Tyler?
Would be quadrilateral.
Yeah, it's just quadrilateral. There is nothing, based on the information given, there's nothing special that we can say about it. None of that, and I know it's kind of confusing because there's a lot of stuff being said, right? But there's not enough information to say anything else. I know this diagonal is bisected, but I don't know this one is, so I can't even say that it's a parallelogram. Right? I know these are congruent, I know this is 9, but I don't know that this is 9. So again, can't say it's a parallelogram. Okay, so not enough information to say anything else, so our fallback is quadrilateral. All right. Any questions about 7.5? You might see some proofs in there, okay? We didn't go over one together, but you might see some proofs in the homework, okay? Use those theorems to help you out.